Welcome back to the flipped classroom. Our topic today is adding and subtracting fractions. We have two main goals today. First, we want to find a least common denominator. And second, once we have that common denominator, we are going to only add the numerators together. In example number 1, 2/15 plus 4/15, you'll notice that we already have a common denominator. So since that already exists, all I'm going to do is simply add the numerators together. So 2 plus 4 gets me 6, and I would say my answer is 6/15. Now unfortunately, it's not always going to be that straightforward. Most of the time, you're going to have to get your own common denominator. So in example 2, we have 3x/4 plus x/8. My goal is to look at these two denominators and see what they have in common. The least number that they both go into is 8. Now, you might be thinking, well, why not 4? Well, they're both divisible by 4, and 4 certainly goes into 4, but 8 does not go into 4. So again, I'm looking for a number that they both go into, and 8 is the smallest one that works. So I'm going to rewrite each fraction with a denominator of 8. The second fraction already had the 8, so all I'm going to do is simply rewrite it. This first fraction, however, has a 4 as the denominator, and I need it to say 8. So I'm going to multiply the top and bottom by 2. This will get me an 8 on the bottom. So I'm left with on top, 2 times 3x is 6x. Now that I have a common denominator, I'm going to only add the numerators. So 6x plus x gets me 7x all over 8. My last step is just to make sure this fraction is reduced, and of course 7/8 has nothing in common, so this is a simplified fraction. Example 3. I have 1/6x plus 2/3x minus 3/4x. Alright, so again, our goal is to focus on the denominators, and I'm going to start with the 6, the 3, and the 4. And I'm just looking for a number that all three of those go into. And I would say the smallest number they go into is 12. Now you certainly could pick a bigger number, and that's okay too, but we're usually looking for that least common denominator, the smallest number that they all go into. So again, that number is definitely 12, and each term has an x, so I'm going to use a common denominator of 12x for each term. And again, I'm simply going to rewrite my denominators and then determine what I need to multiply each fraction by. So I simply say, how does 6x become 12x? Well, I have to multiply by 2. So on top, 2 times 1 is 2. Now each one's different. How does 3x become 12x? Well, I simply have to multiply by 4. So on top I get 8x. And lastly, 4x becomes 12x by multiplying by 3. So on top I'll have 9. Now once my denominators are all the same, I'm simply going to add the numerators together. So I have 2 plus 8, which is 10, minus 9, leaves me with a 1 on top, and I'm keeping the denominator. So my final answer is 1/12x. Alright, now example number 4, we have to pay close attention to this minus sign. This sneaky little guy causes lots of problems, so take your time here. So again, I'm only going to focus on my denominators first, and I'm going to start with the letter A. I have an A and an A squared, so the number they both go into, or variable they both go into, is A squared. And when I talk about the B's, I have a B squared and a B, so I need to take the B squared. They both go into that. So I'm just going to rewrite both of these fractions with that denominator. And again, I'm saying I have AB squared, and I need it to say A squared B squared. So all I have to do is multiply this term by A, and I'm going to wrap this top in parentheses. On the bottom, I have the A squared B, and I need it to say A squared B squared. So I need to multiply this part by B. Now, there's one little catch we talked about, and it's that minus sign. I want you to change this minus sign to an addition sign, and that's perfectly legal, as long as you change everybody after it. So if I make this a plus, and we've done this before in class, I need to change both the signs of these two. So I'm going to cross that out and rewrite this as negative A minus B. So let me say that one more time. You can change subtraction to addition if you change the signs of everybody after them. This was positive, now it's negative, positive, now it's negative. So I take this a and distribute on top. I get a squared minus ab. We've called this a plus sign now. And if I take this b and distribute on top, I've got a negative ab and a negative b squared. Now that my denominators are the same, I'm simply going to leave the denominator and add only the numerators together. And if I take a peek, I have an a squared, and it looks like I have negative ab and negative ab, so minus 2ab, and of course minus b squared. So make sure you take your time on these and be real careful with those negative signs. Remember, we can change a negative to a positive if we change every term after it. I've got just a few more for you. There's a couple little tricks, so stay with me here. All right, number 5, a little different from the previous ones. 2 over a minus 3 over a minus 5. So first thing I'm going to do right away is I'm going to get rid of this minus sign by turning it into a plus and then making everybody after it the opposite. Well, there's only 3, so I only have to make that one term negative. Now, when I talk common denominators this time, I have a monomial and a binomial. So I have to take both of those. So I'm going to say I need just an a, and then I need the quantity a minus 5. So again, monomial and binomial, I need to take both of them. So this fraction, I'm going to say my denominator is a and a minus 5. Plus this denominator as well, a and a minus 5. Remember, I am taking both of them. So this had only an a, I need both, so I'm going to multiply this term by a minus 5. This had the a minus 5, it needs the a, so this term only gets multiplied by a. So as I distribute this 2, I've got 2a minus 10, and this will give me a minus 3a. Lastly, now that my denominators are the same, I'm going to add the numerators. So the 2a and the negative 3a go together, making a negative a, and I have a negative 10 on top. On the bottom, my common denominator is a and a minus 5. Now, some people are going to start trying to cancel this a and this a, but notice this is being multiplied and this is being added. Therefore, you cannot cancel them, and thus, this is our final answer. All right, number 6, let me give you one very similar to that previous one. You try it on your own. Pause it, give it a whirl, and then go through mine and see if you agree with it. So right off the bat, I'm changing this to a positive and making this a negative. I have a monomial and a binomial, so I need both of them. So I've got an x and an x minus 4. This fraction has the x, it needs the x minus 4. This fraction has the x minus 4, it needs the x. So I have 4x minus 16, this is a plus now, negative 6x. Last step, keep the common denominator, and I'm going to add any like terms on top. 4x, negative 6x makes negative 2x minus 16. Now I actually can go one step further. You'll notice that the top has a GCF. So I'm going to pull out a negative 2, and when I divide by negative 2, that's going to leave me with a positive x and a positive 8. And I've got my x and x minus 4. Now, nothing happened to cancel, but if it did, I would cancel anything I could and simplify. So this is my final answer. Okay, just 2 left. Make sure we're taking good notes here. All right, number 7. I've got 2 over x squared minus 36 minus 1 over x squared plus 6x. So again, right off the bat, I'm changing this negative to a positive and making this guy negative after it. Now you'll notice something that we didn't have before. These denominators should look familiar. We can factor them, and let's make a note right away. Okay? If possible, we want to factor first, and I mean factor our denominators before we try to do anything. So hopefully you're saying you see perfect squares, so x plus 6 and x minus 6, and I'm not going to touch the numerator. And on the bottom, I don't see perfect squares this time, I see a GCF. So I'm going to pull out an x, and I'm left with x plus 6. Now this denominator is much messier than we've seen in our previous examples. So remember, you need a common denominator. You need one of everybody you see. So I see an x plus 6. There happens to be one there too, so I definitely need an x plus 6. I see an x minus 6, and I see a plain old x. So since I need one of everybody I see 3 different things. So my common denominator is a plain old x, an x plus 6, and an x minus 6. Okay, so take your time. We need one of everybody we see. So now just ask yourself, this has the x plus 6 and the x minus 6. It's missing the x. So I'm going to multiply the top only by x. This second term has an x and an x plus 6. It's missing the x minus 6. So I'm going to multiply by the x minus 6 here. So on top, I'm left with 2x. And on the bottom, just distribute this negative through, negative x plus 6. All right, we've got our final cleanup here. Rewrite your denominator. And I'm going to put any like terms I have together. So I'm looking at a 2x and a negative x for a positive x plus 6. Now you'll notice we're not actually done here because I see the same quantity on the top and the bottom. So this is not simplified yet. This would be the incorrect multiple choice answer. So I can simply cross off anything on the top and bottom that are the same. Now that doesn't leave me with anything. When I divide, I get a 1, of course. So I'm going to say my final answer is 1 over x and x minus 6. Well, all right, folks, we made it to our last and final problem, and hopefully you've taken your time on these notes. I would say this one is pretty tricky. So go ahead, copy it down, and I think you'll notice that these denominators look pretty darn close to being the same. Now, they're not the exact same, but again, they look close to it. The 2x is positive, now it's negative. The 6 is negative, now it's positive. And that should look familiar to you. Hopefully you're saying they're different by a negative sign. So here's the trick. First and foremost, you had to catch that. Now since they're only different by a negative, I can just take a negative and multiply it by one fraction here. And again, I just have to do it to the top and the bottom. In doing that, what that does is I get a negative 9 on top, and now I'm going to get a negative 6 and a positive 2x when I multiply this. And that is going to match this denominator. So again, I just caught that these were different by a negative, so I'm going to multiply this fraction by a negative 1. So I'm going to get a positive 2x minus 6. And again, that's so handy because it matches this denominator now. Now that the denominators match, I'm simply going to add the numerators together. So 3 and a negative 9 make a negative 6 all over 2x minus 6. Now remember, if I can factor anything, that's my goal, but you'll notice I cannot cancel this negative 6 and this negative 6 because we're not multiplying terms together. So I can factor the bottom, and I'm going to get 2 over x minus 3. Now nothing cancels, but again, my goal is to factor and see if anything does. Well, I hope you've done okay with this section on adding and subtracting fractions, and we look forward to any questions that you have in class tomorrow. Have a great night.